Hello guys, this is Uspa Tutorials, and today we are taking distance between 2 points on a line. That's the distance between 2 points. Yeah, actually, a point on a plane is specified by the distance from two perpendicular lines, and these two perpendicular lines are the y-axis, which is also called the ordinate, and the x-axis, which is also called the abscissa, and the point of intersection of the two perpendicular lines is called the origin, which is at 0. So the line drawn through the origin, this is it. The points in a plane are represented by the distances, as I've said earlier, with the x-axis. Let's say for instance you want to name a point on a plane with the x-axis coming first like this, then comma the distance from the y-axis like this. So back to our topic, distance between 2 points. Let's say this is our point P with the ordinates x1, y1, then our point Q, ordinate x2, y2. So the distance from the the x-axis is drawn, then the distance from the x-axis of Q also is drawn, then we can now trace the distance between the two, here being our x2, then here is x1. So the distance between these two is actually x2 minus x1, and here is y1, this point is y2, so the distance between the two is y2 minus y1. By bringing out the triangle, we get a right angle triangle. This is our P, this is our Q, this is y2 minus y1, x2 minus x1. Then we use Pythagoras theorem. The Pythagoras theorem is all about how to calculate the size of a right angle triangle when you are given a 2 of its side, and it states that the hypotenuse, let's try and name it A, let's say this side is B, and this is the same thing as C. So the Pythagoras theorem says that the square of the hypotenuse, and the hypotenuse is the longest side in the right angle triangle, is equal to the sum of the square of the two other sides, and that's B squared plus C squared. So our A now is PQ all squared is the same thing as our B, y2 minus y1 all squared, plus the C, x2 minus x1 all squared. Then our PQ now, the distance between P and Q, is the same thing as the square root of the sum of the squares as we understood how we got about this square root. It was by adding square root to both sides. By the time you bring square root to PQ, the square here, we can actually cancel the square root we brought over this side, and the square root over this side will stay, the square root here will stay. So let's take an example on the distance between 2 points with example 1. Saying find the distance between points A 3, 2 and point B 4, 6. And the solution of it, in point A, you have the coordinates to be 3 and 2, and I've already told you guys that when given the coordinate of a point on a plane, is actually the distance from the x-axis that comes first, then later the distance from the y-axis. So this one will actually be our x1, 3, then 2 will be our y1, then for B with point 4 and 6. 4 is the distance from the x-axis, so 4 will be our x2, and 6 is the distance from the y-axis of point B. So using the equation we derived, now PQ, that's the distance between our 2 points. So our 2 point now is no longer PQ, is now AB. And the line AB is the same thing as the square root of y2 minus y1 all squared plus x2 minus x1 all squared. Line AB, distance in AB is the same thing as the square root of y2 6 minus your y1 2 all squared plus your x2 4 minus the x1 3 all squared, and that's the same thing as square root of 4 squared plus 1 squared, the same thing as square root of 17. So we can actually leave it in this short form, or we convert it to the decimal form, but it is best advisable to leave it in your short form. So this is actually the distance between the 2 points. Yeah, we are done for today. So in the next class we'll be taking the midpoint of a line segment. So if you really think this video helped you a lot in your academics, you can hit the like button and drop a comment in the comment box below, and please subscribe and share this video. Thank you very much, and for any suggestion you can drop it in the comment box also. Thanks.